Hello, math students. This lesson is going to be on the distributive property. Right here under the Do Now, I've got questions on the two math skills you need in order to be successful in this lesson. Go ahead, pause the video now and try those 4 questions, and then come back to get some answers. So the first 2 questions are related to multiplication. This first one says negative 3 times 5. 3 times 5 is 15. And then anytime you multiply a negative and a positive number, that will give you a negative number. For the second one, it says negative 7 times negative 9. 7 times 9 is 63. And then if you're multiplying the same sign, 2 negative numbers, that will give us a positive answer. For the second part in this lesson, we also need to know how to combine like terms. That's the lesson we did from yesterday, simplifying expressions by combining like terms. We learned yesterday that you can combine 2 things if they have the same variable and the same exponent. For example, a 6z minus 2z. And to do it, you just do math with the coefficients. That's the number in front of the variable. 6 minus 2 is 4. And then I keep my variable, my z. For the second expression, we've got 1, 2, 3, 4 different terms. There are 2 types of terms here. There are my y's. I can combine 6y minus 5y. Make sure you're always using the sign in front of the number. And we can also combine numbers. I can combine my 3 and my 2. It doesn't matter what order you do that in. So if you want to say 3 plus 2 is 5 first, you can do that. When you combine your 6y minus 5y, 6 minus 5 gives us 1y. And so if you say plus 1y, that's fine. But one of the things we learned yesterday is that if you have a variable and you don't see a number in front of it, that number is the number 1. So it's way more common for you to see something like this, just 5 plus y, because I know looking at the y that there's only one y there. You could have written that. You could have also written y, and then that plus 5, that positive 5 goes second. Both of these are okay. So if you have either of those, know that that would be a correct answer. We're going to do a lot of multiplication today and simplifying, similar to the work we did yesterday with combining like terms. This lesson on distributive property also talks about how you can simplify expressions. Our objective for this lesson is I can simplify algebraic expressions using the distributive property. We've used this word simplify a lot in math. Simplify is just making something simpler. So for example, I simplified this expression with 4 terms by combining, and now there's only 2 terms. That's simpler. We learned yesterday as well, algebraic expressions look like these here. There are these expressions that have variables in them. The new part for today is what this means, distributive property. And to help introduce that idea, I've got this question here for you. In part 1, this is similar to what we did in the first lesson from this unit, where I'm giving you some information and we want to represent it with an expression. So the story we are representing says Brianna goes to Subway and pays $5 for a sandwich and $D for a drink. That variable right there tells me I don't know how much money she's paying for the drink. Right now, I just want you to focus on part A. It says write an expression that represents the total cost of Brianna's meal. Go ahead, pause this video and see if you can come up with what our expression could look like. For part A, if we want the total cost of her meal, total means I want to add up all the things she's buying. And so here she's buying 2 things. She's buying that $5 sandwich, and she's also buying that drink for D dollars. Similar to what we set up here with this warm-up question, you could write 5 plus D. You could also write D plus 5. Both of those would be good representations of Brianna's meal. Now, jumping to part B, we're told she also buys the same thing for Jonathan. So what is she buying for Jonathan? Well, she's buying a sandwich for him and a drink for him, same as what she got for herself. And for part B, the same idea. I want to write an expression that represents the total cost of their meals. So both Brianna's meal and Jonathan's meal, how much all of it together costs. I like part B because there's going to be a lot of different expressions you can write to represent the cost of both of their meals. Go ahead, pause the video now, and see how many expressions you can come up with. Don't stop at one. If you can know another way to write it, go ahead and do that as well. So I've been teaching this lesson for a while, and it's always fun to do it in class because you see just how many expressions students come up with for the second part here. Sometimes we'll get something like, well, this is Brianna's meal, and this is Jonathan's meal, and I want to add them together to get the total cost of their meal. So something like this would be correct. I've also had students say, well, if she's getting 2 sandwiches, instead of using addition in the 5 plus 5, we could say she's getting 2 sandwiches that cost $5, and she's also getting 2 drinks that cost $D. And for both of these, you might see them written in different ways. So maybe you did your 5 plus 5 and then your D plus D second. For that second one, maybe you said 2D and you put your drinks first and then the 2 sandwiches at $5 each second. Maybe you even said, well, I don't need to write that second part as a multiplication problem. 2 sandwiches would cost $10. There are so many different ways to write this. That's really cool. The one I like to see that helps us get ready for what we're doing today is this idea of, well, one meal costs 5 plus D. That's the sandwich and the drink. And she's not buying one meal. This altogether is one meal. She's buying 2 meals. This right here, and using multiplication to represent the cost of those 2 meals, is another way you could write this expression. And the reason I want to have this one on our list of expressions is because all of these things I've written up here are all correct ways to represent the story. That means they all represent the same thing and they're all equal to each other. That means this expression right here that we've got is also equal to some of these other ones we've written, like the 10 plus 2D. What we're going to be seeing today are expressions that look like this. And our goal to simplify them is to take away the multiplication and just write it like this, like an addition or a subtraction problem. And the way we get there, you might be able to figure out, how would I go from something like this first line to the second line? Well, that multiplication there tells me we're buying 2 of those $5 sandwiches, but because those parentheses are around everything, the 5 plus D, it also means I'm buying 2 of those drinks. And so to do the math we're doing today, I would multiply my 2 by my 5. That's how we get the 10. But we would also multiply the 2 times D, which here would just be 2D. This right here, what we just did with that double multiplication problem, is what we call the distributive property. And so I like to use this question here because it's related to what we've already done to help introduce this idea of what the distributive property is. In order to do this math, we would say I need to distribute the number 2, which just means multiply. So let's jump over to that vocabulary we're going to be seeing today. We said this right here, the part I did in green, is what we call distribute or distributing. Distribute, when you hear that word, it means there is multiplication happening. We say it's the process where you multiply a term outside the parentheses, like this number 2, to everything inside the parentheses. So notice I multiplied the 2 with the 5, but I also multiplied the 2 with D. You could hear this called distribute. I need to distribute the number 2. You could hear the word distribution. This is an example of distribution, or the name of our lesson, distributive property. Distributive property is just what we call like the rule in math that says this is an okay thing to do. I am allowed to multiply the 2 with everything inside to get something that's equal. So using what we've said here, our definition of distribute, and this one example we did with Jonathan and Brianna's meal, go ahead and there are 3 practice problems here at the bottom. Go ahead, pause this video. You know you want to try this out and see if you can do it before I put up the answer. So pause this video and try those 3 problems at the bottom to see how you're doing. The idea today is we're going to do a lot of multiplying. We're going to multiply the number outside parentheses to everything inside. And so what helps a lot of students is doing those arrows I did up here to help you remember to do both of those multiplication problems. I would say 5 times 4 is 20. And then 5 times 3 I know is 15. So there I get 15x. Don't forget your variable. Make sure you've got an x on your answer. When we come to the second one, I've got 3 times t. Well, that's similar to the 2 times d I did up here. 3 times t is just 3t. Remember, when you've got a variable like t, there's a number 1 in front of it. So if it helps you to think 3 times 1t, you can do that as well. And then we can't forget to do the 3 times 10. That would be minus 30 there. For that last one, it looks a little different, but it's the same idea. I'm taking what's outside my parentheses and multiplying it to everything inside. So here, there's not 1, not 2, but 3 multiplication problems because there's 1, 2, 3 terms inside the parentheses. We've got 6 times 2x, that's 12x. 6 times y, or 1y, would be 6y. And then 6 times 10 would be 60. So I get 12x plus 6y minus 60. That is a simplified way to write that expression because now there's no more multiplication happening with the 6. It's already been multiplied. And so that's what we're doing today. Lots of multiplication. Now, there's something that all 4 of these problems so far have had in common. Here I multiplied 2, multiplied 5, 3, 6. The question I have is what happens when the number you're distributing is negative? So notice I've got 3 down here for us to try now, and instead the number in front of those parentheses is a negative number. The idea is the same. We're going to be doing multiplication, but my advice for you for these is make sure you distribute the sign and the number. And sometimes it helps to break it into 2 steps. So we can always do that as well. For example, for this first problem, I need to multiply negative 3 and 5. So I might start by thinking, well, I know a negative times a positive number is negative. This is going to be true for anything we do. It doesn't matter which numbers you're working with. So I'm going to start by saying negative times positive is negative, and then 3 times 5 is 15. You can always break it into 2 problems if you need. When we go to multiply the second one, I see I've got a negative 3 and not just 2, a negative 2m. So I see here I'm multiplying negative and negative. That is going to give me a positive. So negative 3 times negative 2, I'm going to get a positive 3 times 2 is 6, a positive 6m. So I want to be really clear here. Notice the sign I see here. It changed. It changed to a plus sign. Why did it change? Changed because we were multiplying 2 negatives. So we're not always going to copy down the sign I see inside the parentheses. It's going to depend on what you get when you multiply those signs. Something we didn't mention earlier, but I'm going to mention now is notice I'm also not combining negative 15 and 6m. Why am I not doing that? Why didn't I add any of these together, like the 20 and the 15x, the 3t minus 30? It goes back to what we said yesterday with combining like terms. I can't add or subtract any of these because they aren't the same term. I've got variables and numbers. Here with the 12x and the 6y, they're different variables. And here with my negative 15 and my 6m, we've got a number and a variable. I can't combine those. So this is as simplified as it gets. We did this first one together. The only change here is make sure you're really paying attention to your signs. Go ahead and try these other two problems here and see what you come up with. Once you've got an answer, go ahead and press play on this video. For the second one, we want to do negative 10 times 3g. Well, I know negative times positive is negative. 10 times 3 is 30, so I get negative 30g. And then I also need to multiply negative 10 with that positive 4. Again, I know negative times positive is negative, and 10 times 4 is 40. So I get negative 30g minus 40. Now this last one is fun. Here, I don't see a number. I just see a negative sign. Now you could do that multiplication just thinking of your signs, or sometimes it helps people to think of that negative right there in front of the parentheses as a negative 1. Just like we said yesterday, if you have a variable with no number in front, it's the number 1 as the coefficient. The idea here is similar. I don't see anything in front of my parentheses, just a negative sign. That would mean the coefficient is negative 1. So here it might help to think of multiplying negative 1 to everything inside. Not necessary, but it can help a lot of students. Either way you do this, you're going to get negative y minus 2z. And so this is distributing. We're talking about multiplying what's outside the parentheses to everything inside. Now we can make these problems a little more fun by combining what we learned yesterday and what we learned today with distributive property and looking at expressions that look something like these. Looking at this first one, it says 9 times 2x plus 2 plus 3. Looking at this problem, before we do any math, can you tell what's different about this problem compared to everything we've done so far in this lesson? Well, that difference is that plus 3 there. All of our problems didn't have something extra at the end, right? It just had that multiplication problem we had to do. But here, I'm seeing I've got that extra addition part. I've got that plus 3 there. Thinking about everything we've learned with simplifying, I see this first part here. This looks like what we were doing today with multiplication. But I also see that plus 2 plus 3. I maybe want to add those together. Using those mathematical brains of yours, what do you think I should do first? Should I do that multiplication part first or that addition part first? Well, we can use order of operations, PEMDAS, BODMAS, whatever you use, to help you know that that multiplication is going to happen before addition. And that's not just true in this problem. That's true always, that we want to do multiplication before addition or subtraction. That means in these problems where we see some multiplication and addition or subtraction, we want to always first distribute, because distributing is that multiplication. So starting with this first example here, I want to start by distributing. I want to multiply my 9 with everything inside the parentheses. That means I would get 18x plus 18. What do you think? Am I multiplying my 3? I'm not. I'm not multiplying that 3 because we said we distribute to what's inside parentheses. This is not inside the parentheses, so I'm just going to copy that down. That part right there in purple, that's my first step. Once we've done that, then we can do any other simplifying we see. So I know this is not completely simplified because yesterday we learned we can combine like terms. So looking at this problem here, I see there are 2 like terms. It's those 2 numbers. Don't forget, you can add 2 numbers together. So that would be my last part. I want to say 18 plus 3 is equal to 21, a positive 21. And then that 18x, that's just what I'm copying down. Now remember, you can write 18x plus 21, or you can always put that 18x, that positive 18x at the end, and put your 21 first. Both of those would be correct. They both mean the same thing. This right here is going to describe the order that we're going to do these problems in. If you see an expression where you can distribute and combine stuff, that distributing always happens first because multiplication happens before addition or subtraction. I love these problems because you get to practice what you learned in this lesson and what you learned in the last lesson. So looking at this problem here, what is the first thing you want to do? Let me tell you, so many people say, okay, I see 5 minus 2, I want to do 3, and then that's the number I'm distributing. This is no good. Why can't we do that? We just said we've got to do that distributing first. 5 minus 2 is not distributing. That's a subtraction problem. Another way you can think of this is 5 minus 2 times 9y plus 8. That's actually the same thing as minus 2 times 9y plus 8, and then putting that 5 there at the end. These both mean the same thing. That 5 is just like this extra number in the problem, it's the same as that plus 3 was over here. And so that is why we're not doing that subtraction first, is because I could have seen that 5 at the beginning or at the end. We want to start with the distributing. So let's go ahead and do that. Let's start with our distributing. When I go to distribute, I'm distributing not just that 2, but a negative 2. Let me actually keep my distributing purple. I'm taking my negative 2 and I'm multiplying that with everything inside the parentheses. Since I'm not doing any multiplication with my 5 is just going to copy down. And I've got negative 2 times 9y, that's negative 18y. And negative 2 times 8, that is negative 16. So this is my first step. After this, I'm going to go ahead and I'm going to combine like terms. So again, I've got numbers I can combine. I've got a 5 and a negative 16. 5 minus 16 is negative 11. Got a different sign, so you're subtracting. Keep the sign of the bigger number. And then I'm copying down my negative 18y. Same order of the steps for this first example here. Changing it around to this problem I wrote here in black isn't necessary at all. But if you did do the problem over here, you're going to get the same answer because these two expressions are equal. They're equivalent. So we did 2 together, and guess what? Below, I have 2 problems for you to try now. Again, really make sure you're pausing this video and you're trying them on your own. It's good practice and a good way for you to check in and see how you're doing. So go ahead, pause this video now and try these 2 practice problems. This first one here, I think, is very similar to this one we just did, because I see that 3 plus 8. Maybe you really wanted to add 3 plus 8, but we can't. We got to do that distributing first. That 3 should just be copied down, and then I can say 8 times b and 8 times 4 would give me 8b plus 32. After that, we can combine some like terms. I can say 3 plus 32 is 35, and then I have that positive 8b still. This would be our final answer. For that second one, did you have fun with it? Because to me, it sure looks fun. We need to start with the distributing, and I don't have just one distributing problem. We have 2 of them. I need to multiply my 5 times x and my 5 times 7. That gives me 5x plus 35. But then look, we've got a second multiplication problem. Did you distribute negative 2? We need to do negative 2 times x. That would be negative 2x. And negative 2 times negative 3. Did you catch those negative signs? Negative times negative is positive. 2 times 3 is 6. But wait, we're not done. The fun continues because I see I've got some like terms. I've got 5x minus 2x. 5x minus 2x gives me a 3x. And then I also have numbers I can combine, 35 and a positive 6. 35 plus 6 would be 41. And so we get this right here as our final simplified expression. These right here are going to be really important for some lessons we have coming up when we talk about how you can use this to help you solve equations and solve different problems. The final thing I want us to look at are these bottom two right here. I really think these are fun because it's the same math we've been doing, but more in a puzzle. The idea here is to find the missing number. So that would be these empty boxes right here that we would need to make this expression equal to negative 6x minus 2. And then the same thing over here. I also have in the directions, I want you to convince me why you're correct. So if you think this missing number should be the number 5, how could you prove to me that that number 5 would give me what's over here on this side? Again, these are for you to try. So go ahead, pause this video and try to see if you can come up with either of these missing numbers. When I'm looking at these, sometimes it might just take some mistakes to help you figure out what that missing number would be. For example, I put a 5 here earlier, not because I thought it was a 5, but just as an example. But the reason it wouldn't be 5 is because 5 multiplied by 3x isn't going to give me the negative 6x. And it's also not going to give me negative 2. One of the things you might have noticed first is if you ask yourself what number multiplied by 3 gives you 6, that could help you figure out that missing number needs to be a 2. 2 times 3 would give me 6, and 2 times 1 would give me 2. But if I only put 2 here, it's not going to give me exactly what's over here. One of the things I'm noticing is that all our signs changed, and that happened because this must have been a negative. With that second part that convinced me why you're correct, you could do that actual multiplication for me. I know I'm correct now because negative 2 times 3x would give me negative 6x, and negative 2 times 1 would give me negative 2. And that's what we've got over here. So we must have gotten it right. Now the second one here, oh my goodness, there's a lot more going on. I see I've got a multiplication problem, and we also have that 4a that's being added as well. If I look at what I can do here, I have this distributing problem I would start with first, and I don't know what this would be, but I do know 5 times 2 would be giving me a 10. And I see that 10 is already there. I see I'm supposed to be getting 29a, and all I've got right now is 4a. So that also helps me figure out this part right here must be an a. There must be some sort of a because I'm supposed to be getting up to 29 of them, and I only have 4 a's right now. If I just put a there, and I did this multiplication, 5 times a is 5a, and then I would still have that 4a in front. My problem here is I still don't have enough. 4a plus 5a is 9a. I'm supposed to be getting 29 of them. So that means this multiplication problem here, there must be more than just 1a. You can kind of do the problem in reverse. If I already have 4a's, how many more would I need to get to 29? In other words, 4 plus what would give me 29? Well, 4 plus 25, that would give me the 29a I need. So after this multiplication, if I had 4a plus 25a plus 10, that would simplify to 29a plus 10. So then the last step is we're going to keep working backwards here. If I know this should be 25, 5 multiplied by what would give me 25a? Well, 5 times 5 gives me 25. So that helps me know this missing term right here should be 5a. Now, when it comes to the convincing part, the best way to do this is actually do the problem. If I wanted to multiply first, I would say 5 times 5a is 25a. 5 times 2 is 10. And then I bring down my 4a. After that, I see I can combine like terms. I could combine 4a and 25a to get 29a. And then I'm bringing down that 10. And look, that's what we've got over here. For ones like this, sometimes it's easier and you know exactly what that number is you need, but other times don't feel bad about putting in some wrong numbers. Like I started with a there and then I had a 5a. Over here I started with 2 and then I put in a -2. Don't feel bad if you need to put a wrong number there first to help you figure out what it might be. Just by putting some number there, it's going to help you see what math you would need to do, like that 5 times what gives me 25, to help me find that missing number. These are problems that not everyone gets the right answer on the first try. Sometimes it takes trial and error. But I do like these problems because it makes us think about this distributing in a different way. This is the last part I have for you on this lesson on distributive property. Remember, the idea of distributive property is to help us simplify. It's this idea of multiplying whatever you have in front of a parenthesis to everything inside to help do that multiplication problem and simplify our expressions. Thanks so much for watching. I hope this helped. See y'all.